Hi children, today we are going to be discuss 7th class, second chapter, that is fractions, decimals and rational numbers. In that exercise number 2.6 from bit number 6, 7, 8 and also exercise 2.7 I am going to be explain you 2.6 and 2.7. 2.7 based on rational numbers. Okay, then here let us start with our 6th bit. Already up to 5th bit I have done in the part 1. So let's go for the 6th bit. Yes. Solve the following. Here we will get the division of decimals. In the 2.6 till 5th bit we have multiplications of decimals. Now we are going to learn division of decimals. Let us see that first one, that is 2.3 divided by 100. Let's first of all we write, we know that how to change the decimals into fraction and fractions into decimals. Okay, first of all we write 2.3 divided by 100. Simple. So let us first of all we'll remove this decimal point to be convenient us. Directly we can do it, but we'll remove the decimal point. If you are removing the decimal point from the numerator, we'll get 1 0 in the denominator. That means we'll get 1 tenths. 23. We have removed the decimal point, so we can write here 100 and one more 0 because of this one decimal digit. Okay, this one decimal digit we have written the whole part. So for that decimal digit I have kept one more 0 in the denominator. Okay, this is what we got. Now the change the fraction, now 23 by 1000 change into decimal. This fraction will change into the decimal. Simple. First you write the 23. See that how many zeros are there in the denominator? 3. We count the 3 digits from the right side here in the numerator part. 1, 2. Only 2 digits are there. The third digit we have to keep as a 0. That is 0, 2, 3. Now we got a 3 digits. Put a point. Before the point there is no number, so 0. So this will be the answer. 2.3 divided by 100 will get 0.023. Simple. When you are dividing this, decimal point will move the left side. When you are multiplying, this decimal point will move the right side. When you divide, this decimal point will move the left side. When you are multiplying, this decimal point will move the right side. That means value will be increases. This decimal is move this side, the value is decreases. When you divide, the value will decreases. When you multiply, the value will be increases. So when value is increasing, the decimal point will move the right side. When value is decreasing, the decimal point will move the left side. So we are dividing. So this decimal point will move the left side. How many digits move the left side? 2 digits. So this is one more digit. You have to give one more digit, that means 0. 0.023. This decimal point will move the 2 digits. This is one more digit. If you keep a 0, here it will comes directly. So this is the process how you got that 0.023. Now we go for the second question in this, that is 0.45 divided by 5. Simple. What I am going to do it first, this 45. Okay. First 0.45 divided by 5. No, I will write 5. Now after that, here in the numerator part there are 2 decimal places. So we will remove the decimal digits. We get 2 zeros in the denominator. That means 2 zeros 10, 100. 5 to 100 or 5. Directly to write 2 zeros. Now we have to cancel this. Okay, we have to cancel this. Or else what you do it, directly you can divide. When you have a mind, just go through that. 5 ones are 5. Here 0 is there, 0.0. 0. What you will get? 0.9. 0.9. Directly you got 0.9. When you divide it, directly you will get. Division is possible. In the 5 table you know. So directly you cancel, you will get answer here. Then third one. That is 44.3 divided by 10. Okay, let us see. This 44.3 divided by 10. Simple. Let us in the same model we will do it. First we will write 443. We will remove the decimal point. so that we get 1 0 in the denominator. One more 0 is increased because this decimal point is very remote. Now this fraction will change into the decimal. Okay, here decimal will change into the fraction. Fraction will change into the decimal. The denominator, how many zeros are there? 2 zeros are there. We'll count the 2 digits in the numerator. 1, 2. That is 4.43. As I told you, we are dividing by 1 0. No? That means tens. So this decimal point will move the right side, left side once. Okay, when you are dividing, it move the left side. No? So we are dividing by tens. It moves the 1 digit. When you are dividing by 100, it moves the 2 digits. When you are dividing by 1000, it moves the 3 digits left side. Okay. If it is move the 1 digit as a left side, that is 4.43, you will get the same answer we got here. Okay, very simple. We have to think once what we are doing it. The fourth one, 127.1 divided by 1000. Simple. The 3 digits is moved. 3 digits, if it is moved the left side, what happens? Here 1 digit, 2 digit, 3 digit. So 0.127.1 you will get. So 0.1271. Okay, let me do that first. 127.1 by 1000. Simple. This decimal point I have to remove. So 1 0. I have to keep a 1 0 in the denominator. No? Let me write 1271. Here decimal point I removed. So already there are 3 zeros in the denominator. I'll keep one more 0 because we are removing one decimal point, decimal digit here. Now you count that this is fraction will change into the decimal. How many zeros are there in the numerator? Sorry, denominator there are 4 zeros. So we count the 4 digits here, 1, 2, 3, 4. So after the 4 digits we have to keep a decimal point. That is 0.1271. This is what. See fourth one. Then fifth one. 7 into 3.5. 7 into 3.5. Here 7 into, this is 35. Sorry, divided. It is not a multiplication, simple. Sorry children. 7 divided by 3.5. Here we do it. 7 divided by 3.5. Here also the same. In the denominator we have one decimal digit. This will remove it. So we'll get 1 0 in the numerator. When you are removing decimal digit, decimal point in the numerator, you will get the zeros in the denominator. When the decimal point you are removing the denominator, you will get 0 in the numerator. Okay, remove in the numerator part. If you remove the decimal point, you will get the 0 in the denominator. In the denominator, if you are removing the decimal point, then you will get 0 in the numerator. Okay, denominator lo remove cheste numerator ko ostadi, numerator lo remove cheste denominator ko ostadi. Interchange avutadi. Okay, I hope you understood. Here 35 ones are 35 twos are. That equal to answer is 2 direct. 35 ones are 35 twos are 70. So 2 by 1 is nothing but a 2 only. The answer will be 2. Here the next one, sixth one, 88.5 into 0.15. So here we do it first. 88.5 divided by 0.15. First, we'll remove all the decimal digits and we'll write the number. Here 0.15 is nothing but a 15. That means 15. So we have to see now. In the numerator, there is only one decimal digit. So we'll keep 1 0 in the denominator. In the numerator part, we removed one decimal digit that we had in the whole part. This decimal point we removed. After this decimal point, we have only one digit. So we kept 1 0 in the denominator. In the denominator, after the decimal point, we have 2 digits. So we have to keep 2 zeros in the numerator. Simple. Now we have removed the decimals. Now we can do the solutions. 1 0 1 0 get cancelled. Yes. Now we'll do it. Yes. In the 3 table you can cancel. Or not. In the 5 table you can cancel. 5 3s are 15. Here 5 1s are 5. 3 left. That is 38. 5 7s are 35. 3 left. That is what? Here 35 again. 5 7s are 35 again. Then 15. In the 3 table you can cancel. 3 1s are 3. 3 5s are 15. 2 left. That is 27. 3 9s are 27. That is what is 59 as a answer. So there is only one more problem is left. That is seventh one, that is 0.4 divided by 20. Yes, 0.4 by 20. In the numerator we will remove the one decimal. Then here in the denominator 1 0 will be increases. Here 4 ones are 4, here 4 5s are 20, and 4 zeros 0. That means 1 by 50 you have. 1 by 50. This we have to be expressed in the form of decimal. 1 by 50 is nothing but a 1.02. That means you divide this 1 by 50, 0.0, again 0, 2s are 100. That means 0.2 you will get, 0.2. Okay, in the R not you can do it in another method. I will tell you that. Simple. This you do it like a 0.4. We'll write as a 4 by 10. This you do at a 4 by 10. This is divided by 20. Divided by 20. Then here let us do it. This 20 will write as a 20 by 1. If there is no denominator, we can write 1 as a denominator. Then 4 by 10. This when division by division, that means one fraction divided by another fraction. Then this division become a multiplication and do the reciprocal of the next one. So what you get here? 2 ones are 2 5s are 20. Again you get same again. Here 1 by 10. Here 1 by 5. 1 by 50 you will get. Okay, 1 by 50. Same 1 by 50 again. The same process we have done it. So if at all you are confusing, you do the same. Then you will get the answer as a 0.02. Okay. Then do that 0.002. 0.002 you will get as the answer. You just do it, you will get answer. Then we go for, there are two more word problems here. 7th one and 8th one. We go for the 7th one first. See that a side of a regular polygon. There are two kinds of polygons actually. Polygon is a simple closed figure bounded by the line segment. There are two kinds of polygons said. One is regular polygon, one is irregular polygon. Regular polygon is all the sides having equal length. If all the sides and angles are equal in a polygon, that is called as a regular polygon. If any one of the side or angle is unequal, it is called as a irregular polygon. Polygon is a simple closed figure which is bounded by the line segments, like squares, rectangles, square, triangles. These are the polygons. If all the sides and angles are equal, that is called regular polygon. Like a square, all the sides are equal and all angles are equal, so it is a regular polygon. Irregular polygon, for example, rectangle, all sides are not equal, so all angles are equal but all sides are not equal, so it is a irregular polygon. So you got an idea about regular polygon and irregular polygon. Here what is given that a side of a regular polygon, the length of the side is given. Okay, length of a one side is equal to 3.5 centimeter. Length of a one side is 3.5 centimeter of a regular polygon. The perimeter of the polygon is given. Perimeter of a polygon is equal to 17.5 centimeter. The perimeter in the sense the sum of all the sides. The sum of all the sides is the perimeter of the polygon. That is 17.5 centimeter. He added all the sides of a polygon. Then you got 17.5. In that one side will be 3.5 centimeter. As he said, it is a regular polygon. So all the sides having equal in the length. So we have to find how many sides does a polygon have. How many sides? The number of sides of a polygon here. The number of sides of a regular polygon. Here he mentioned regular polygon in the sense all the sides are equal. The complete perimeter is 17.6 centimeter. That we have to divide by 3.5 centimeter. This means the sum of all sides is 17.6 centimeter. 17.5 centimeter. All sides are added, so we got 17.5 centimeter. From that, one of the side is given 3.5 centimeter. If total length, the total length by you divide by one length, you will get number of sides. How many sides it has? centimeter get cancelled. Here what we need to do it simple. So here 175 you write, here 35 you write. In the denominator and numerator there are one more decimal digit. So keep 110 on the both the sides. For numerator decimal point we kept 10 in the denominator. For denominator 1 decimal point we kept 10 in the numerator. These two zeros will cancel. So let us see either it is able to cancel or not. Directly it can be able to cancel. Now you get a number of sides actually. So we'll cancel in the 7 table first. So 7 5s are 35, 7 2s are 14. So 3 left, that is 35. 7 5s are 35, 5 1s are 5 5s are. Therefore, how many number of sides are there? There are 5 sides of the regular polygon. How many sides a regular polygon have? There are 5 sides. How many sides? Therefore, the number of sides of a regular polygon. Therefore, number of sides of a regular polygon is equal to 5. There are 5 number of sides. If each side is 5.5 centimeter, 3.5 centimeter, see the regular polygon, it is a pentagon. 3.5 centimeter, 3.5 centimeter, 3.5 centimeter, and 3.5 centimeter, and 3.5 centimeter. Complete this perimeter is 17.5 centimeters. So how many sides it has now? 5 sides. So it is called regular polygon. So let us see one more question, that is the 8th question, that is last question of this 2.6 exercise. See the 8th one solution. A rainfall of 0.896 centimeter was recorded in 7 hours. Okay, the rain recorded, therefore the rainfall recorded in 7 hours is equal to 0.896 centimeters. Okay, 0.896 centimeters was the rain was recorded in first 7 hours. What is the average amount of rain per hour? In 1 hour, how much rain is fall? Okay, so the rainfall in 7 hours 0.896. In 1 hour, the rainfall we need to find out. Therefore, in 1 hour, the rainfall equal to the average rainfall in 1 hour, or we can write here the average rainfall in 1 hour, rainfall in 1 hour is equal to 0.896 centimeters by 7. Average we have to take. So sum of the observation by number of observations. There are 7 hours. We have to divide this 7 hours. If you divide, you will get in 1 hour how many centimeters of rain is fallen. Let us divide here. 7 ones are, first here there is a 0 point, you keep it. 7 ones are 7, 1 left here, 8 is there. So that 1 will comes here. The 9 become a 19. 7 twos are 14. So here there is a 19. So 5 left, that is a 56. 7 eights are 56. That is 0.128 centimeters of rainfall in 1 hour. The average rainfall in 1 hour equal to 0.128 centimeters. So I hope you understood this exercise 2.6. Then we'll discuss exercise number 2.7. 2.7. So in the 2.7, what we are going to learn about rational numbers. There is the third one. Already we discussed about the fractions. We also discussed about the decimals. Addition of fractions, subtraction of fractions, multiplication of fractions, division of fractions we discussed. Here the decimals, addition, subtraction, multiplication, division of the decimals. Now we will discuss about the rational numbers. Rational numbers in the sense, rational numbers mainly denoted by a Q. Rational numbers are denoted by Q. What is meaning of a rational number in the sense? The numbers which we are able to write, in the fractional form are P by Q. the numbers which you are able to write in the form of p by q, where p comma q are integers, p comma q are integers and q is not equal to 0, such kind of numbers are called as a rational numbers. The numbers which we are able to write in the form of p by q, where q is not equal to 0 and p comma q are integers, such numbers are known as a rational numbers. So here about rational numbers, I have done a clear video in the properties of rational numbers. Okay, if you type a properties of rational numbers, then you will get my video in my channel. And also I'll keep this the rational number video in the description. You watch that so that you will know the completely what is rational numbers. Okay, before rational numbers we know there will be integer numbers, whole numbers and natural numbers. So this all you will discuss there, and which kind of numbers are known as the rational numbers also I told you. So there are some decimal numbers are also known as the rational numbers. Which numbers are able to write in the form of p by q? Nothing but p by q is nothing but a fractional form. Which numbers are able to write in the form of numerator by denominator? The numbers are called as the rational numbers. That's it. So about the rational numbers you have to watch a video. Here I am not going to be discussed about much about the rational number, but I am going to solve all the problems from this 2.7 exercise. Okay, here about the rational numbers, the video link I will give in the description. You need to watch it before you watch 2.7. Now you watch it, then come again and continue this video. Okay, then here the first bit, the 2.7, write any three equivalent rational numbers of each of the following. Equivalent rational numbers, nothing but equivalent fractions like only. So I will tell you first one. Any three equivalent rational numbers. First one is given 2 by 3. For 2 by 3, it is a positive rational number. Minus 2 by 3 is a negative rational number. Okay, whatever. Plus 2 by 3, it is a positive rational number. Let us find out three rational equivalent rational numbers. To get the equivalent rational number, nothing we have to do it. See that this 2 by 3, you multiply this. With 2 by 3, you multiply to the fraction, this rational number you multiply to the numerator and denominator, you multiply with the same numbers, you will get equivalent rational numbers. So 2 2s are 4, 3 2s are 6. Okay, 4 by 6 is a one of the equivalent rational number of 2 by 3. Then next one, see 2 by 3 into I go for 3 by 3. You have to multiply with the same number to the numerator as well as to the denominator. Then only you will get equivalent rational number. 2 3s are 6, 3 3s are 9. Okay, 2 by 3 into, you can also multiply by 4 by 4, 5 by 5, 6 by 6, any number. Okay, there is no matter what number you are multiplying. I will once, for example, I will do by 10 by 10. But we have to take same numbers in the numerator and denominator. 2 10s are 20, 3 10s are 30. So if you simplify this, again you will get equal to 2 by 3 only. See, 2 2s are 4, 2 3s are 6. Okay, 3 2s are 6. 3 3s are 9. Okay, 10 2s are 20, 10 3s are 30. Again 2 by 3 only will get the equivalent fraction, that equivalent rational numbers are 2 by 3. Therefore, the equivalent rational numbers of positive rational number it is. So 2 by 3 equal to 4 by 6 comma 6 by 9 comma 20 by 30. How many you can write? Infinitive you can write here. It is a positive rational number, so the equivalent fractions of positive rational number is always positive. Here it is positive, so you will get all positive only. If it is negative here, the equivalent rational numbers you will get negative only. Because if it is minus 2 by 3, always we put minus minus minus, so you will get here minus minus minus. So the equivalent rational number of a positive is always positive. The equivalent rational number of a negative is always negative. So it is a positive, we got all positive equivalent rational numbers. Here we have one more question. It is a negative rational number. 3 by 8. 3 by 8 is a negative rational number. Let us do it here. Minus 3 by 8. Let us find out the equivalent rational number. Further we need to multiply it in the same number with the numerator and denominator. No? Have done. Minus 3 into 6. Sorry. Minus 3 into 2 minus 6. 8 to the 16. Then we do it minus 3 by 8 into 3 by 3. Let me do it. Minus 3 into 3, that is minus 9 by 8 is 24. Okay, minus 3 by 8 into, let me go for 4 by 4, minus 12 by 8 4 is 30. So you got 3 equivalent rational numbers. He has only 3, we are going for only 3 here. So the equivalent rational numbers of minus 3 by 8 are equal to minus 6 by 16, minus 9 by 24, minus 12 by 32. So here it is the negative rational number, their equivalent rational numbers also will be the negative. Here it is a positive rational number, the equivalent rational number of positive number is always positive. So in this way, equivalent rational number in the sense nothing but it is equal to equivalent fractions only. So we have to given number, we have to take a given rational number, we have to multiply with the same number to the numerator as well as to the denominator. Numerator and denominator, if you multiply with the same number, you will get equivalent rational numbers or equivalent fractions. Okay, here we are discussing about the rational numbers, so we use the word of only rational numbers. Here the second bit. Okay, here the second question only. There is only one question and it is an important question here in this exercise. What is the equivalent rational number for minus 15 by 36 with the denominator 12? The first question. The given rational number is equal to minus 15 by 36. Okay, here we ask the first question in that with the denominator 12. With the denominator 12. So we have given a denominator. Simple. Minus 15 by 36. The equivalent fraction is given. Numerator he did not give anything. The denominator he gave 12. So for a time being, let us assume the numerator as a x. We don't know what is that. That is a blank. Okay. So we have to find out here what is the x. Simple. Now here 12 is dividing. If division terms, if you transport to the other side, that become a multiplication. As I told you, the transporting term that you learn in the next exercise, that next chapter. If the division term, if you transport to the other side, if you transport to the other side, that become a minus. If minus, if you transport to the other side, that become a plus. If division, if you transport, that become a multiplication. If multiplication, if you transport, that become a division. The transporting terms from LHS to RHS side, RHS to LHS side. It will be like that. So here see minus 15 by 36. This division 2, you transfer to the other side, that became a multiplication of 12. Here 12 is dividing, the 12 will be multiplied here. So that we get x. What we need? We need a x value. So we'll make it x is alone here. Here x is alone. Now we'll find out. 12 ones are 12, 12 threes are 36. Yes. 3 ones are 3, 3 fives are 15. So here x equal to what we got? Minus 5 we got. Minus 5. Therefore, the numerator equal to minus 5. You got the numerator as a minus 5. So here second one, he is given the second question in the only numerator minus 75. Numerator is minus 75. Here is given with the numerator minus 75. We have to find out. See, the given fraction is minus 15 by 36. Here numerator is given minus 75. The denominator he did not give. So the denominator let us assume like a x. Okay. The denominator we have to assume like a x. Then we'll find out here what is the x value. Simple. For this, we'll do the criss-cross multiplication. Criss-cross multiplication. We'll say that this is a criss-cross multiplication. So this two we need to multiply and this two we have to multiply. So let us multiply minus 15 into x equal to minus 75 into 36. Yes, 75 by 36. So what we have to do here, minus 15 is multiplying to x, but we need a x value, not minus 15 x value. So this minus 15 not required here. We have to transport the side. So minus 15 is multiplying. So minus 15 will divide when you transport. Here I told you the multiplication term become a divisor. So here multiplying, minus 15 is multiplying to x. So that minus 15 is divides the other side if you transport. Minus minus get cancel. 15 1 is 15, 15 5 is 75. So x equal to 5 into 36, that x equal to 180. 5 is the 30, 3 carry, 5 3 is the 15 plus 3, that is 18, that is 180. Therefore denominator equal to 108. Denominator equal to 108. I hope you understood this. This problem is very important. This transporting terms you will learn in the next chapter in the simple equations. So simple. The transporting term in the sense when you transport one term to the other side, LHS to RHS or RHS to LHS side, these things will be taken place. Then plus become a minus and minus become a plus, into become a division and division become a into. So that you need to be remember. Okay, in our next class, I'll also explain you that what is transporting terms, what is simple equations, what is variable, what is constant terms, everything I will explain you. Okay, then let us go for third bit. Mark the following rational numbers on the number line. We have to find out this on the number line. Let us first one 1 by 2. 1 by 2 we have to mark on the number line. So which number line here we are going to learn? Not integer number line, it is a rational number line. So we have to take here 0. So we have to observe what is the denominator here, 2. So here you have to take first 1 by 2. Then here you have to take 2 by 2, 3 by 2, 4 by 2, it will be continuous. 2 by 2 is nothing but a 1. 4 by 2 is nothing but a 2 ones are 2 twos are, that is 2. See, here actually the left side of the 0 will be minus negative values. So minus 1 by 2, minus 2 by 2, minus 2 by 2 is nothing but a minus 1. Here minus 3 by 2, it will be continuous values. But what we require, only 1 by 2 is required. 1 by 2 is where it is? It is here. We'll mark like this. We'll highlight the 1 by 2 only, not on this all numbers. Okay, to get understand I have written here. So normally we have to focus on the denominator. That denominator will tell us how many partitions we have to do it. How many partitions we have to do it on the number line. Okay. So first of all we have to put a 0. So this denominator is 4. That means between 0 to 1 there will be 4 partitions. That means here it is 1 by 4, it is 2 by 4, it is 3 by 4. It is 4 by 4 and it is 5 by 4. So when you see here 4 by 4, 4 ones are 4 ones are. So completely here it will be 1. 1, 2, 3, 4. That means 0 to 1. Here it is 0, here it is 1. 0 to 1 there will be 4 partitions. Here it comes minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4. Is nothing but here also minus 1. It is not necessary that here we are written plus 5 by 4. We have to write till minus 1 by 4. These are the not required numbers. What we need actually only plus 3 by 4. This we need to highlight. That's it now. We don't look for the other numbers. But it is necessary that right side of the 0 that is the positive rational numbers. The left side of the 0 is negative rational numbers. And the third one, that is 3 by 2. So 3 by 2. Let us do it 3 by 2. First always 0 and here the denominator 2, that means between 1 and 2 there will be 2 partitions like 1 by 2, here 2 by 2, here 3 by 2, 4 by 2, 5 by 2. 2 by 2 is nothing but a 1. 4 by 2, 2 ones are 2 twos are, that is 2. Here minus 1 by 2, minus 2 by 2, minus 3 by 2, minus 4 by 2, minus 5 by 2. Minus 4 by 2 is nothing but a minus 2. Here it is minus 1. What we need to be highlighted here, what we need to mark 3 by 2. Here it is 3 by 2, plus 3 by 2 is here. Okay. Then next 10 by 3. 10 by 3, that is the fourth one. 10 by 3 we have to mark. Okay, let us try to do it here. It is 0 here, 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3, 6 by 3, 7 by 3, 8 by 3, 9 by 3. Here it is 10 by 3. Here minus 1 by 3, minus 2 by 3, minus 3 by 3. Okay, 3 by 3 equal to 1, 6 by 3 equal to 2, 9 by 3 equal to 3. Here it is minus 1 and go on. But what we need to highlight 10 by 3. Where is the 10 by 3? Here is the 10 by 3. I need to mark on that 3 by 2. This is a rational number line. How it is the integer number line? The same way we get the rational number line. Rational number line. Here only the denominator will tell us that how many partitions we have to do it between two numbers. If the denominator is 2, the 2 partitions will be taken place. If denominator is 4, the 4 partitions will be taken place. So here third bit, that means third question is completed. This is the fourth bit actually. The fourth bit is true or false actually. True or false? True or false? Every integer is a rational number and vice versa. Every integer is a rational number, it's vice versa in a sense. So the reverse of also will be, every integer is a rational number, it is true, but vice versa in the sense, the reverse of it. Rational, every rational number is an integer? No. So the first one is a false. Every integer is a rational number, that is true, but every vice versa is a, vice versa in the sense, the reverse of this statement, that is every rational number is an integer? No, it is a false. So further the first statement is a false. The second one, listen. In a rational number of the form p by q, yes, rational number in the form of p by q, q must be non-zero integer. Yes, q must be non-zero integers. Q should not be equal to 0. That is what he said. So the given statement is true. The third one is, every decimal number can be expressed as a rational number. No, it is a false. There are some decimal numbers we cannot be expressed in the form of p by q. There are two kinds of decimal numbers. One is terminating decimal number, the other one is non-terminating decimal number. Terminating decimal number can be expressed in the form of p by q. Yes, they are considered as a rational numbers. Non-terminating decimal numbers, there are two types again. Non-terminating repeating decimal numbers, non-terminating not repeating decimal numbers. The non-terminating repeating decimal numbers can be expressed as a p by q. Non-terminating not repeating decimal numbers cannot be expressed in the form of p by q. So here every decimal number cannot be in the form of p by q. We cannot write in the form of p by q. So every decimal number cannot be considered as a rational number. To know about these statements, what I told you till now about the decimals, already I have done a video about the decimals. That video also I will give in the description, or not type in my channel, you will get about decimals. You will get about the decimal complete information. So which are the decimal numbers are known as a rational numbers, and which are the decimal numbers are not known as a rational numbers. We will be knowing it. Here 5 by 6, 5 by 7, 6 by 7, 7 by 7. Is this are equivalent rational numbers? No, they are not equivalent rational number, because these three decimal numbers, the fraction rational numbers, having no same value. If you cancel this 5 by 7, 6 by 7, 7 by 7, you will not get same value. It's not same value. So it is not an equivalent rational number. So it is a false statement. The fifth one, equivalent rational number of positive rational numbers are all positive. Yes, equivalent rational number of all positive values are positive. So equivalent rational numbers of all negative values are negative. That we have done in the first bit in this exercise 2.7. With this our chapter is completed. Second chapter is completed. In my next video I will explain you about the third chapter in the simple equations. So till that time practice this chapter properly, so that you will get a good knowledge about the fractions and decimals and rational numbers also. So in the 8th class we will learn about the rational numbers completely. That is the first chapter. So this will be rational numbers is helpful till 10th class. You have to study well in the about rational numbers and about decimal. The two videos links I will keep in the description, or not you have to type in my channel, you will get that both videos links also. Watch completely to get a good knowledge. And thank you for watching this video. Have a nice day. Bye.